Hey guys, this is Ujjwal Kumar Sen and you are watching Ujjwal Kumar Sen English YouTube channel. So guys, in this video we'll discuss 20 more question from question number 61 to question number 80, right, in RAC, refrigeration and air conditioning. So let's get started. Question number 61. In this question it is saying a refrigerator operates between temperatures of minus 23 degrees centigrade and 27 degrees centigrade. If 1 TR is equal to 3.5 kilowatt, the minimum power required per TR to operate the refrigerator. Just focus here, put the focus here my dear, per TR. That means it is talking about refrigeration effect is equal to 3.5 kilowatt. And we have to find out work input as it is saying in this question as power input. So we know that COP in terms of temperature for refrigerator, that is minus 23 plus 273, because TL by TH minus TL, so 27 minus plus 23 is equal to refrigeration effect upon power required, P. So refrigeration effect is 3.5, so P is equal to, this one is 50, right, and this one is 250, right, so this cancel, right, 5, so P is equal to 3.5 by 5, so it's 0.7 kilowatt. Therefore answer for this question is what? Option B is the correct answer for this question. I hope you got the point. Next, question number 62. An ideal refrigerator is operating between a condenser temperature of 37 degrees centigrade and evaporator temperature of minus 3 degrees centigrade. If the machine is functioning as a heat pump, its COP of performance, matlab means coefficient of performance, will be, right? So let's draw the diagram. Let's say it's a heat pump, right? This should be like this. So that is saying 37 degree and this one is saying minus 3 degree. For this case we have to find out COP. So we know my dear what is the formula for COP? TH by TH minus TL. So TH is how much? 37 plus 273 in the denominator, that is 40, so it is 310 by 40. This cancel, 7.75. so answer for this question is what? Option D is the correct answer for this question. Question number 63. A Carnot heat pump works between temperature limits of 277 degrees centigrade and 27 degrees centigrade. If it's COP, so my dear, we have to find out COP, right? So we know that COP of heat pump is very simple question. COP heat pump is what, my dear? TH 277 plus 273 by 277 minus 27. So what is the answer we are getting? Basically, let me tell you, 277 plus 273 division 277 minus 27. So what is the answer we are getting? That is 2.2. Therefore option C is the correct answer for this question. My dear, one more thing, if you are preparing for examination where calculator is not allowed, don't practice using calculator. Try to use pen and notebook and practice questions, right? Don't use calculator, right? So 64 number question, very simple question asked in ESC already. In an aircraft refrigeration system, the pressure at the cooling turbine outlet is equal to, right? My dear, in case of aircraft refrigeration system, the pressure of cooling turbine outlet is equal to the people sitting in the aircraft pressure. That means cabin pressure, right? People will sit in the cabin, right? So it is equal to cabin pressure. If it will not equal to cabin pressure, there will be problem in the refrigeration effect and we cannot get overall good output. That is why that should be equal to cabin pressure. So answer for this question will be what, my dear? Option B is the correct answer for this question. Now let's move to the question number 65. In gas cycle refrigeration, an engine is used instead of throttle valve for pressure drop of the refrigerant, because, my dear, what is the function of throttle valve? We use throttle valve to maintain enthalpy constant and decrease the pressure of the refrigerant. In that case we can get we can get cooling effect. We can get cooling effect in the evaporator by doing this, right? But what will happen in case of gas cycle refrigeration? We cannot use throttle valve because it cannot give us that much effect, that much cooling effect, that much output. That is why we use engine. That is why, what my dear, we use engine, because enough cooling or temperature drop is not obtained by throttling. My dear, one more thing. Throttling process is also known as isenthalpic process, because in this process enthalpy is constant. And my dear, in case of VCRS, if we'll go for VCRS TS diagram, this one is right, dash line always there because it is reversible. So 3 to 4 is, my dear, what? This is the throttling process. Here we used throttle valve in case of VCRS, vapor compression refrigeration system, right? Now question number 66. In a 3-ton capacity water cooler, water enters at 30 degrees centigrade and leaves at 15 degrees centigrade steadily. What is the water flow rate per hour? My dear, this question already asked in ESC. Similar question, right? So it is a very simple question. We know that, my dear, here we are going to use elephant formula. I call this as elephant formula. Q is equal to MCPW dt. Why I am telling it as an elephant formula? Because this formula is used in RAC, in HMT, even in thermodynamics. This is an amazing formula, my dear. So I call this formula as elephant formula. You can remember it also like this, right? Okay, so my dear, here you have given 3 ton, means always remember it is asking per hour, not per second, right? So this will be m dot, means mass flow rate. Its unit would be kg per second, and later we have to convert this into kg per hour. I hope you're getting me. So Q is how much? Q that the Q rate of heat flow is how much? My 3 ton, means 3 multiple 3.5. Mass flow rate CPW 4.186 kilojoule per kg Kelvin, and dt 30 minus 15 is 15, right? Now solve this and you will find out the value. You have to multiply the value with what, my dear? 3600 in order to convert kg per second into kg per hour, which is required in this question. Solve the problem till the answer in the comment box, because there is nothing more to do. Just you need to do simplification, nothing else, right? I hope so you can do that, because you are getting education from me, so you can able to do that. I think so. So question number 67. A refrigerator that operates on a Carnot cycle is required to transfer 2000 kilojoule per minute to the atmosphere at 27 degrees centigrade, where the low temperature reservoir is 0 degrees centigrade. What is the power required? Very simple question. My dear, we have given refrigerator. Whenever we have given such type of question, always look at what they are asking, refrigerator or heat pump. Otherwise what will happen? You know everything, but because of hurry you will make mistake, and that is not, you cannot afford to lose any marks from this type of question, because this is very simple, very common question, right? I mean, at least those are doing well in classroom, even in at home, they can easily able to solve this problem. So my dear, if you will not solve this problem, that means you are losing by so many rank. So my dear, you have to solve this type of problem with maintaining accuracy. So always look at what they are asking, refrigerator or pump. So my dear, we know that what is the formula for refrigerator to find out COP in terms of temperature, that is TL. So 0 plus 273 division TH minus TL 27 minus 0 is equal to what, my dear? Refrigeration effect upon power, that is work input. We have given refrigeration effect in 2000 kilojoule per minute. Here you will make mistake again, my dear. We have to convert this into per second. So for that, my dear, we have to divide 2000 by 60. Alright, so it is asking kilo, so we don't need to change the kilo, just let it be kilo, no problem. P, and solve this problem, the find out the answer of P. Let me solve this, because I have already given you task, right? So I can solve this, I think so. Okay, so it's, my dear, 273 division 27, so it's 3.296 kilowatt. So answer for this question is what, my dear? Option D is the correct answer for this question. It is 3 point, yeah, it is equivalent to that, right? So option D is the correct answer for this question. Question number 68. An ideal refrigerating machine works between refrigerating machine. That means we have to find out the case for refrigerator. Till now, so far, what we have read in this question. Works between the temperature limits 45 degrees centigrade and minus 8 degrees centigrade. The power required per ton of refrigeration is. How much power required per ton of refrigeration we have to find out. Per ton, always remember, it is talking about per ton, right? That means refrigeration effect is how much, my dear? 3.5 kilowatt. So again, the same type of question we are getting again and again, right? So it will be quite easier for you. So TL minus 8 plus 273 and TH minus TL, that means 45 plus 8 is equal to 3.5 by P. So we have to send this part to denominator and this part to numerator. So P is equal to, what is the value we are getting? Let me tell you. Minus 8 plus 273 is how much, my dear? 265. Division 53, right? And 3.5 division that answer. So it is 1.7 kilowatt. Therefore, answer for this question is what? Option D is the correct answer for this question. Question number 69. Two reversible refrigerators are arranged in series and their COPs are 5 and 6 respectively. The COP of composite refrigeration system would be, my dear, we have to implement the concept of cascade refrigeration system, right? So according to that, for composite refrigeration system is equal to what, my dear? COP 1 multiple COP2 division 1 plus COP1 plus COP2. So here, my dear, 5 multiple 6, 30 and 5 plus 1, 11 plus 1, 5 plus 6, 11 plus 1, 12. So 2.5. Therefore, answer for this question, what, my dear? Option B is the correct answer for this question. Question number 70. During an air conditioning of a plant, the room sensible heat load is 40 kilowatt and room latent heat load is 10 kilowatt. Ventilation air is 25% of supply air at full load. The room sensible heat factor will be. We have to find out room sensible heat factor. Amazing question, my dear. I must say that. Amazing question, right? Because it is saying ventilation air is 25%. So you always tag it 25% what is saying. But the answer for to find your answer of this question is quite simple. Let me write you that formula. Room sensible heat factor is equal to room sensible heat divide room total heat. That is room sensible heat plus room latent heat. What is latent heat, my dear? Whenever there is phase change, there is no difference in temperature, that is what, my dear? Latent heat. There is no phase change, we can sense the temperature, that means there is temperature difference, that is what, my dear? Sensible heat. Always remember that. So room sensible heat 40, room sensible heat 40, room latent heat 10. So 40 by 50, this cancel. So what is the value, my dear? 0.8. So answer for this question is what? Option B is the correct answer for this question. Question number 71. The enthalpy of moisture with normal notations is given by, my dear, direct formula. You just need to remember how to find out enthalpy of moisture here. The formula is here. 1.005 plus 1.88, that is not W, that is omega multiple T plus 2500 omega, not W. Omega means specific humidity or humidity ratio, right? That is omega is equal to 0.622 PV division P minus PV. Always remember this, right? Now, question number 72. If the relative humidity of atmospheric air is 100%, the wet bulb temperature will be, my dear, it is talking about the saturated condition. In case of saturated condition, relative humidity will be 100%, and in that case, my dear, what will happen? DVT, dry bulb temperature, is equal to wet bulb temperature is equal to DPT, dew point temperature. In this case, even, my dear, wet bulb depression is equal to 0, because wet bulb depression is equal to dry bulb temperature minus wet bulb temperature. That is why wet bulb depression must be equal to 0. So answer for this question would be what, my dear? Equal to dew point temperature. Therefore option B is the correct answer for this question. Question number 73. In an Electrolux refrigerator, a thermo-siphon bubble pump is used to lift the. I mean, why we use this pump in case of Electrolux refrigerator? That is, it is asking basically, right? In case of Electrolux refrigerator, one trick you need to remember: we used pair of refrigerants, right? How many pair of refrigerants? That is important, my dear, to know. And basically, Electrolux refrigerator is a noiseless operation. Remember that it is a noiseless operation. You must remember that, because I have seen question, they have asked question from this, and we use pair of refrigerants. What is the pair of that? Let me tell you, right? That is NH3 we are using as refrigerator, then H2O we are using as absorber, and H2 is used to create low pressure of NH3 in the evaporator, then condenser. My dear, these all terms asked by different competitive examination, maybe ESC, maybe SSC, maybe PSUs also, right? So you must know these all things, because Electrolux refrigerator is so simple and you can easily answer the question, right? Now, very important, what is the function of this? That is here. Weak aqueous solution, it is used to lift weak aqueous solution from generator to the separator, right? So answer for this question is what? Option A is the correct answer. Question number 74. Which of the following refrigeration system is most suitable for solar cooling? My dear, what are other names of solar cooling system? One is VARS. That will answer of this question, that is vapor absorption refrigeration system. Also known as, my dear, waste heat recovery system, right? Also known as, my dear, what, my dear? We use this refrigeration system where the cost of electricity is too high. There we used this refrigeration system. Please remember that. Now, question number 75. During sensible cooling process, specific humidity. Whenever you are getting such type of question, especially from psychometry, always come to the psychometry chart. It is talking about what? Sensible cooling. And this is specific humidity. What will happen to specific humidity, my dear? As you can see in the diagram also, it is not changing. It is constant. So answer for this question will be what, my dear? Option C is the correct answer for this question. Question number 76. Comfort condition in air conditioning system are defined by. How we can able to define this? That is option D is the correct answer. 2 degrees centigrade DVT and 60% relative humidity. 77. Which of the following is not an essential component of any refrigeration system where refrigeration effect is produced by evaporation of refrigerant? Very, very important, my dear. That is what? Compressor. Because in case of VARS, vapor absorption refrigeration system, we do not use compressor because that is not essential for us. Instead of compressor, we used rectifier, analyzer, and then pump, absorber, as well as generator. So what is exactly compressor is doing in VCRS? In case of VARS, all these components, generator, pump, rectifier, analyzer, absorber, doing the same job for this refrigeration system. That is why option C is the correct answer for this question. Question number 78. Which one of the following compressor will be used in vapor compression refrigerator for plants up to 100 tons capacity? My dear, if it is required 100 tons capacity, then my dear, reciprocating compressor is good. But it is required more than 100 tons, then we must go for centrifugal, right? So answer for this question is option A is the correct answer. Question number 79. Another question, my dear, very amazing question, and you must know, my dear, CFC refrigerant. What is the refrigerant name of CFC refrigerant? Chlorofluorocarbon, right? Nowadays we are not using it. That is what, my dear? R502. Another question I wanted to ask you, what is the other name of this R500 plus refrigerant? That means R502. This question, from this refrigerant name, they have already asked question in ESC also. Now, my dear, R744, that is what? CO2. Just look at this. C12 and 700 plus should be there, and O2 is 32. So that is 744 is for CO2, right? And 290 that is for propane, right? Propane. and 718 for water. Just look at water, 2 plus 16, right? And that is 718 because for this case, for inorganic refrigerant, what will happen? We have to consider refrigerant number from 700, starting from 700 for inorganic compound, right? So you should write that. Okay. Now guys, let's move on to the next question. So this question is done. So option C is the correct answer for this question, right? Question number 80. For a small installation of refrigeration system up to 35 kilowatt, which type of condenser is used? My dear, air cooled condenser up to 5 kilowatt, double tube condenser up to 10 kilowatt, cell and coil tube condenser, my dear. What will happen in that case? Up to it should be up to, my dear, around 50 kilowatt, and shell and tube should be, my dear, what around 1000 kilowatt, right? Shell and tube, which is really amazing. So you can remember this: air cooled 5 kilowatt, double tube 10 kilowatt, cell and coil up to 50 kilowatt, and then cell tube, my dear, up to 1000 kilowatt. So my dear, answer for this question, what option C is the correct answer for this question. So my dear, thank you very much for watching. So like the video, it will help me, it will inspire me to create more and more videos for you. Next guys, we have launched our NLC test series. For non-technical, we are providing 60 plus tests and its cost is only 299 rupees, right? And technical, we are providing 10 full length tests and its price is only 149 rupees. You must buy it and start practicing, right? You have to buy right now and start practicing at least non-technical portion, because you will lack in that portion. Technical, I am helping you to prepare pretty well. You can buy also this one because we are providing different question over there, not the same question, right? So guys, thank you very much for watching. Bye bye, see you soon, and God bless you all.